Okay, so I'm going to do a couple examples of solving rational inequalities, and I'm going to go through the steps here as I work out number one. So the very first thing that you want to do is you want to rewrite the inequality so that one side is 0. So right now, when we look at number one, we have a 2 on the right-hand side, and I need to get this to be a 0. So I'm going to subtract the 2 over. So now we have x over x minus 4, and we just have to put the minus 2 right here, less than or equal to 0. Okay, step 2, this one is a little bit lengthy, so we're going to simplify. And that means we have to find the LCD. So on these, when you find the LCD, it's kind of nice because it's always just going to be this thing right here. So our LCD is x minus 4, and this 2 is over 1. So we need to multiply this by the LCD, x minus 4 over x minus 4. And now comes the simplifying part. So once you multiply here, we're going to write this whole top part out. So we have x minus 2 times x plus 4 over the LCD less than or equal to 0. So this top part we're going to simplify. So we have to distribute the negative 2. X minus 2x minus 8 over the LCD. Combine like terms. So x minus 2x is negative x minus 8. And I want to take out a GCF. Now there's nothing you can take out here except this negative 1. It's going to make it easier on you if you go ahead and take that out. So when we take out negative 1, we're left with x plus 8. And now I'll put that LCD in there, x minus 4 less than or equal to 0. So step 2, you can see, is all the way from here down to here, finding the LCD and then just simplifying the top. And it's basically the same every single time. Step 3, we want to identify the critical values. So what that means is it's the x values that make the numerator and denominator equal to 0. So we've done this before. The critical values, though, we called before, we found the zeros and we found the vertical asymptotes. So on here, off to the side, actually I'm going to come up to the top here so I have more room. We're going to write critical values. And we basically want to take the top and set it equal to 0, and then take the bottom and set it equal to 0. So on the top we have this x plus 8. So if we solve that, x plus 8 equals 0, we would subtract the 8 over. So one of our critical values is x equals negative 8. Then we take the bottom, x minus 4 equals 0. Add 4, so x equals 4. So your two critical values, you're going to take those and we're going to put them on a number line. So we're going to take negative 8, because that would be the smaller one, and positive 4. So up here in the steps, it might be a good idea right here, after you find the critical values, place the critical values, I just put CV, on a number line. So after you put them on a number line, then step 4, test an x value in each interval, and I'll tell you what that means, to see if it satisfies the original inequality. Original inequality. So what does that even mean? Okay, so since we're not solving an equation, when we solve an equation that has an equal sign in it, we are going to get x equals something, or x equals negative 5, x equals 2. So specific numbers. On here, you're going to get something like x could be less than negative 8. So it could be an entire set of numbers. So we have to test. We have 3 different intervals here. We have this one less than negative 8. We have the one in the middle, less than or in between -8 and 4. So let's see if I can color code here a little bit. We have this one, we'll call that the orange interval. Then we have the one in between -8 and 4, so I'll do green. And we have the one after 4. So I'll use purple. Okay, so I have 3 different intervals I have to test and see which one of those are going to be my answer. Now on a number line, we always put either open or closed circles at our numbers. So open, remember, means the number is not included. So since -8 came from the top, we got that from the top here, it always matches your sign here. So if this is an equal to sign, then this is going to be a closed circle. Okay, the bottom one, we got the 4 from the bottom, is always open. So I'm going to leave that open. Okay, so now we have to test the intervals. So I need to pick a number in the orange interval. So here's -8. I need to pick something less than -8. So I'm going to say x equals -10 because that's less than -8. Then I'm going to pick something in the green interval. So something in between -8 and 4. Let's go with something easy like 0. X equals 0. And then I need to pick something after +4. So I'll pick +5. Okay? And we're going to test those in our simplified form right here. Okay, so in for the x's, I'm going to put that number I chose. So I'm going to say -1 times 10 plus 8 over 10 minus 4 is less than or equal to 0. So I put the, oh, sorry, it's a -10. Put the -10 in for the x's. So then rewrite the same thing with the zeros. -1 times 0 plus 8 over 0 minus 4 is less than or equal to 0. And I'm going to put question marks here because we need to know, is that true or is that false? And then I'll do the last one, the purple interval, -1 times 5 plus 8 over 5 minus 4. Is that less than or equal to 0? So we're going to test each interval. Okay, so let's test. We want to see if when I plug in these numbers, they are less than or equal to 0. So here we have -10 times 8, that's a -2. -1 times -2 is +2. Over -10 minus 4 would be -14. So this would reduce to 1 over -7, which is less than 0. So this is true. So if it's true, that means I can shade this interval. So then the second one, 0 plus 8 is 8. 8 times -1 is -8 over 0 minus 4 is -4. That reduces to a +2, which is not less than 0, so we say false. Then this last one, -1 times, this would be 13. So -13 over 5 minus 4 is 1. -13 is less than 0, so that is true. So that means I can also shade this interval. So we have 2 intervals that are shaded, and that's going to be my answer. So on this one, we're going to say x is less than or equal to -8, or because I have 2 pieces, I have to say or x is greater than 4, and that is going to be our answer. Okay, so let's do another one. Let's see what I have room for. We'll do number 5. So number 5, we're going to subtract the 3 over first. Okay, find the LCD. Again, it's just this binomial. So x minus 6. So this -3 needs the x minus 6 over x minus 6. So we're going to write that whole top part out. So I have x minus 3 times x minus 6 over the LCD is less than or equal to 0. Okay, we're going to distribute that -3. So x minus 3x plus 18 over the LCD. Combine like terms, so x minus 3x is -2x. And again, if you have a GCF on the top, we want to take that out. So I'm going to take out a -2. So I'm left with x minus 9 over x minus 6. So our critical values, I'm going to come up to the top here again. Our critical values, we solved the top. So if I solve this, x minus 9 equals 0, I would get positive 9. And if I solve the bottom here, x minus 6 equals 0, I would get positive 6. So that's what goes on our number line, positive 6 and positive 9. Now we got 6 from the bottom, which is going to be an open circle, always, from the bottom. And we got 9 from the top, so I look at the sign. It's equal to, so I'm going to put a closed circle. So we need to test a number. So we want to test a number less than 6. So I'm going to pick, I'll pick 0. I want to test a number in between 6 and 9. So I'll pick 8. That's an 8. And I want to test a number to the right of 9. So I'll pick 10. Okay, we're going to plug that into this simplified part right here. So negative 2 times 0 minus 9 over 0 minus 6. Is that greater than or, sorry, less than or equal to 0? Then the next one, negative 2 times 8 minus 9 over 8 minus 6. Is that less than or equal to 0? And then the last one, negative 2 times 10 minus 9 over 10 minus 6. Is that less than or equal to 0? So now we want to check it. This is negative 2 times negative 9. That's positive 18 over negative 6. That would be negative 3. Is that less than 0? Yes, so that's true. The second one, I get negative 2 times negative 1. That's positive 2 over positive 2. That would be positive 1. That's false. And the third one, negative 2 times 1 is negative 2 over 4. That would be negative 1/2. That is less than 0, so that's true. So this one's like the first one where we have the two outer intervals shaded. So we have x less than 6 or x is greater than or equal to 9. So one that we didn't do, I'm just going to come up here and make one up on your interval. Let's say we have 2 and 6, and we'll put a closed circle and an open circle. If the middle is shaded, so when you check it, if this middle part ends up being shaded, you write just one piece. So you'd say x2 is less than or equal to x, which is less than 6. Okay, so when you have the outer pieces like this, it's 2 intervals. When you have the inner piece, it's just the one, the x is in the middle. So that would be your answer.